Hey everyone, geophysicist Stefan Burns here. We are right now in a G2 geomagnetic storm that very likely could enhance to a G3 level. The scale rating goes to 5. This would put us in a strong geomagnetic storm capable of potentially interacting with power grids and technology, causing problems to our modern way of life. We're going to talk about how these sort of solar storm impacts can trigger potentially power grid problems and technological problems, because when you have a really sudden solar storm impact and it is of a sufficient strength, it even has an EMP characteristic to it, an electromagnetic pulse. It can generate that. We actually saw that with this solar storm impact. The initial impact of it was very, very strong, generated a temporary EMP. Doesn't seem that right now there's any technological problems that are occurring, but we're going to dive into what can occur with that, because we are in solar cycle 25 maximum all the way through 2026, and then we'll start to go down through the descending phase and actually get a lot of powerful solar storms during the descending phase. So we're looking at about 4 years ahead of us of greatly increased risk as it relates to strong solar storms and technological failures, perhaps as a result of that. And now we are more dependent than ever on technology. We have so many more satellites in space than we did even just 10 years ago because of all the expansion of Starlink. Now there's 8,000 plus Starlink satellites up in orbit. And we also, of course, have the deployment of 5G and other very high frequency cellular systems, which are very much more interacting with Earth's geophysical system than older radio frequency technologies, because 5G is absorbed into water. Then there's also been continuous alterations of the atmosphere, or more by humans. So we are looking at a more volatile system geophysically on Earth year by year. Earth electrification is increasing, and so we should be well aware and apprised of what is happening, unfolding here on our planet. We did have a question come in from James, who's very generous. And it says, have you heard of Tartarian boots? Mysterious historical earthing boots with inlaid crystals. No, that sounds very interesting. And because you mention it, only because you mention it, you know, on the website Wild Free Organic, I do sell earthing boots. And so, you know, these are kind of similar to that. These are all leather, and they're very much like the type of shoes you'd wear 2,000 years ago, help connect you to these earth energies, which is really important to do at this moment in time when there are these increased energy fluctuations. Not only does that affect technology, it also affects us, because we are actually much more complex technologically, you could say. Our bodies are bioelectric, and there's a whole nested sequence of different vibrations and resonances. And so this works with us at a cellular level, and then at a molecular chemical level, and then even down to the atomic level and below, the quantum level. So these sort of boots, or just in general going outside, being barefoot, earthing, grounding, connecting to Earth's electrical charge, is a really good way to help stabilize your bioelectric system, maintain a harmonious biofield. Just in general, lower cortisol, inflammation, pain. It's a good thing to do. Just a note right at the outset of the video. So let us look. Oh, and by the way, at the end of the video, we are going to do a cosmic connection meditation. I'll do a sound healing. I'll play some different tuning forks here. And I also have my crystal bowl. So we'll play that, which is really good for just helping you rest, relax, and get into that parasympathetic system, and to help connect to and work with these energies. So stick around for the end of that. That timestamp will also be in the video description, so you can click right to it and it will be ad-free. Let us look at this electromagnetic pulse, and then let's get into the data. Here is when this solar storm first impacted. I captured the moment. We're a few hours beyond this now. This is a 3-hour model, but I have about 90 minutes of data here, maybe a little bit more. But here's my Earth's magnetic field. We see our legend there. So we see these colors were just basically normal fluctuations like you get. And look how quickly that pulse all of a sudden caused massive swings to Earth's magnetic field. So going from 0 in the equatorial and mid-latitude regions, all of a sudden higher up to these like 100, 150 nanotesla readings. And then the high latitude regions, the polar regions, all of a sudden going straight up to 400 plus nanotesla. really wild. And we have our latest model right now showing what's happening because we are in a G2 storm right now. This is looking like it's going to continue for a while. Let's get this up on the screen. Here are the geomagnetic fluctuations that we are in right now. So this is going back 3 hours. You can see it's even stronger than that initial pulse. So very powerful geomagnetic fluctuations right now. We're going to talk about Earth's magnetic field, the movement of the magnetic pole in the northern hemisphere. We'll talk about that a little bit, what it's been doing, provide a little bit of clarity as to that. You can see that there's these variations. It was really strong about 2.5 hours ago. It looks like it's just cooled off a little bit. So let's watch this one more time, and then we'll go to the real-time solar wind so we can see why these magnetic fluctuations have cooled off a little bit. But very likely they're going to come back again, because these sort of solar storm impacts can last quite a long time. It's not usually just like a 2-hour thing. And that's where the power grids and the technological failures become more common. The longer it is, the more likely things are to fail. So here we have our real-time solar wind, and let me just refresh this to get the latest data. Here we are, and you can see why our magnetic field fluctuations have gone down a little bit, because the southward component, which connects to Earth's magnetic field, all of a sudden has flipped positive. Earth's magnetic field is also positive in that same Z direction, and so there's not an easy connection right now, but there was. If we zoom in on this, and actually we have 9 hours now of geomagnetic volatility that we've been in. It's already been 9 hours, so there is that. But if we zoom in, we see the start right there, and that puts us at 1633 or so. So 1630 universal time, and then we see sometimes this red line going into this negative configuration. That's the Z component, like the vertical component of the magnetic field. Just an arbitrary way to measure the magnetic flux density in some configuration. And Earth is roughly positive in that direction, so it has to go negative for the solar wind to make that strong connection, push that energy into Earth's magnetic field, the plazosphere, and therefore trigger a strong geomagnetic storm. But see all these southward components right there, those buckets like I call them? That is what gave us these two values here. So this is a 6.33 was our last one, and now it's gone sharply positive. Total strength is about 25 or so right now. Yeah, about 25 nanotesla, 5 times stronger than normal. Normal is 5 nanotesla. Earth's magnetic field, for reference, at the surface ranges from about 23,000 to 67,000 nanotesla. But it decays via an inverse square law. So it decays pretty rapidly. And therefore, it will eventually reach a strength similar to the solar wind of 5 nanotesla, and that is where you have the magnetopause and the solar wind and Earth's magnetic field meet. But if all of a sudden the solar wind gets a lot stronger, it pushes the magnetopause in much closer to Earth, and that causes a whole cascade of geophysical energetic changes, which then can result in, well, first and foremost, a geomagnetic storm, but can also result in enhanced ionospheric currents, because you have electron precipitation, and if it's really heavy, that can actually even be hazardous to spacecraft and satellites and more, which can then short circuit and then burn up and disrupt communications, radio frequency communications like ham radio, and any sort of wireless communication can get really affected during a geomagnetic storm. You can get blackouts, radio blackouts. So right now it's in a northward configuration, but very well could turn southward again before this storm is over. That's almost certain to happen, actually. But let's go to our, just want to reset this for you. You can see that we've actually been in pretty quiet conditions for a while, and now you see this sudden jump up there. So our KP index, a 3-hour measure of geomagnetic field volatility based on swings in Earth's magnetic field strength at the surface, measured at 5 there. It goes to 9, 0 to 9, so it's a 5, that's a G1 storm. And then it clicked up to a 6, and then a 6.33. So that is still just a G2 storm, but we're getting closer and closer to a G3 storm, which is what NOAA forecasted. And a lot of that comes down to the ionosphere. Here we have our GLOTEC model, and check out when this storm impacts the Earth. What are we looking at? This is the ionosphere. And specifically, we're looking at the total electron content, the vertical total electron content. So basically, we're measuring the entire vertical column of the ionosphere and just creating a relative value for the electron content there. And so 100 is the highest, 0 is the lowest, and we see these regions there where it's the highest. That's where you have active solar radiation, charging up the ionosphere. Because not only does the sun emit visible light and ultraviolet light and infrared light, it also emits extreme ultraviolet light and X-ray radiation. Those get absorbed into the ionosphere because they have a high enough frequency. There's also, of course, radio frequency emissions of the sun, like 10.7 centimeter radio flux and others that pierce through the ionosphere. Some of it does get reflected as well. But if we click play on this model again, you'll notice the time. We're getting close to 1630. Watch what happens right at 1630. Boom! Look at the disruption that all of a sudden occurred. Now, this is a model working off of various data inputs and doing its best to display it, so keep that in mind. But we do see that shock also register with the ionosphere and the total electron content initially, and then things started to cool off because now we're back in that northward configuration, but that could change pretty quickly. So we see our ionosphere also registered the impact of that solar storm pretty quickly. And this is important because these electric currents in the ionosphere induce telluric currents in the ground surface. And it's these sort of electric currents that flow through the ground that can cause power systems to have problems. So let me show you a couple graphics here from NOAA, and we'll just go through an understanding of how a geomagnetic storm can affect us. And this should be this is the folder right here. So first and foremost, let me show you this graphic. This is the estimate that NOAA put out for a G3 storm. G3 storm watch for April 16th. It's ready, it actually got here early. It arrived faster than expected. And so let's read the expectation here. A CME is anticipated to reach and impact Earth with elevated geomagnetic response independent on the orientation of the embedded magnetic field. That's the solar wind magnetic field. And then potential exists for strong storm levels. Brooklyn, thank you for the super thanks. 1111. Awesome. God bless. Effects. Limited minor effects to some technological infrastructure is possible, but usually it's mitigatable. The aurora may become visible over many of the northern states and some of the lower Midwest all the way down to Oregon. The general public should consider monitoring our webpage for the latest information and updates. Well, actually, that's why you're watching the live stream. So that is what NOAA has put out for this storm. We've only had a G2 level thus far, but it's still early in this storm. It's likely to continue for at least another 8-12 hours or so, if not longer. So here we have another graphic created by NOAA showing the impact of geomagnetic storms going from G1, which is a KP index of 5 out of 9. That's a minor geomagnetic storm. We get those pretty frequently. Up to extreme, which is pretty rare. We've only had, we had a G5 storm May of last year, May 10th to the 12th. That's the biggest storm that we had basically since 2003. And then we got close to a G5 storm in October of 2024. I think that was October 9th and 10th and 11th, right around that time frame. And I nailed the prediction on that one. That forecast, I was spot on. So we see the range here. Now, with a G2 storm, transformer damage is possible with long duration storms. So this effect can build and build and build. Corrective actions to spacecraft orientation may be required because what happens, you have all these solar particles in the atmosphere, it creates more drag, and so you have to do a lot of, you may have to do corrections for spacecraft to maintain their orbital altitude and their velocity so they don't re-enter and burn up. Aurora may be seen as low as New York and Idaho, so if you're in some of the northern states in the United States, if you're definitely in Canada, then make sure you go out and try to catch some aurora tonight. All you have to do, ideally you have low light pollution, but all you have to do is you go out and look north. You may not see it with your own eyes unless you're up in Canada, and if you are, you probably will. This is a good storm. Definitely see aurora with bright, colorful bands of light. But you can also use long exposure on your camera, like your cell phone, 3-second long exposure. You'll probably get something. Just point it north and you're good to go. But let's read 3 here. Strong. Power system voltage corrections may be required. Satellite and low frequency radio navigation problems may occur. High frequency radio may be interrupted. So that is what they expect for this storm. It came in faster than expected. It has a strong magnetic field. It's just right now in a northward configuration. The ionosphere was really charged up before this storm from a very active sunspot that we had on the Earth-facing side that was continuously flaring. So that is also making this more likely to be stronger. 11 concepts. Thank you so much for the 1111. God bless. Because it's the ionosphere and the electric currents that it creates that generates these magnetic field fluctuations that we feel on the surface. So really the ionosphere is the most important component in some aspects as it relates to a geomagnetic storm that we feel. Now if you get to G4, things can get pretty serious. So possible widespread voltage control problems on the power grid, high frequency radio signal or high frequency radio sporadic satellite navigation is degraded, and we see some other effects there. And then what they say with extreme is that blackouts or complete collapse of power grids is possible. The reason why is because of geomagnetically induced currents. So let us now look at our telluric indices for the United Kingdom. They have a wonderful web page here that we can check out, which shows how the telluric currents vary based off of your location. So we'll get that up right now, and here we go. Here we have from the British Geological Survey our 3-hour telluric index for Lerwick, Eskdalemer, and then Heartland. Rama Lama, thank you for the super thanks. You are prolific with the super thanks. You're an awesome person. Thank you so much. And hello to everyone on the live stream. I'm your host, Stefan Burns. Welcome. We're talking about this solar storm impact that's occurring right now. We're in a G2 storm. It's looking like it may strengthen to G3, and we're running through how this can affect our power grids, technological systems. Also keep in mind, it affects us, our bodies, and more. We are bioelectric. We're affected just as much as technology, if not more. And at the end, we'll do a cosmic connection meditation and sound healing just to help integrate some of these energies, promote harmony and balance, because these energy fluctuations are in general stressful on the body. But we have these 3 locations. Lerwick is like way north. It's like way north of Scotland. It's an island way up there. Then you have Eskdalemer, which is right in general. I'm not an expert at the United Kingdom. I love the place, but it's right in the boundary basically of Scotland and like the United Kingdom proper. And then you have Heartland, which is like way down. I think it's in Wales. It's down to the southwest at the very bottom of the United Kingdom of Britain, of the Isles. So we can see our geomagnetic telluric current indices here. We see that the further north we are, the stronger they are. If we go down all the way to Heartland, look, it's like calm and normal. So down at lower latitudes, these geomagnetically induced currents are weaker because most of that magnetic flux is concentrated in the polar regions, and it's the changing magnetic field which generates these electric currents, which then generates magnetic fields further down, which then generate electric currents. It's this reciprocal relationship that it's turtles all the way down, just keeps going and going and going. They generate eddy currents that cancel each other out. It gets really kind of complicated. Regardless, we see that the further south you go, the weaker the effect. But as we go up to Eskdalemer, all of a sudden, look, some of our values here for the past 3 days reached up to a 6. Right there is a 6. So they reached, in terms of the telluric activity, a G2 level quite a few times over the past, actually this is like a week of data right here. This is going from the 9th of April to the 15th, and we can scroll further back if we want. Then if we go even further into the, like getting close to the Arctic Circle, we see our telluric current indices are even more often at that value of 6. And if we go back, we see that they had values there of 7 up there in Lerwick. I hope I'm saying that correctly. And then we see how that, overall changed going back down here. And if we go back one more, we'll see we even had some really high values. I think it's actually maybe 2 more. There it is. Look at that value right there of 8 for the telluric current indices up in Lerwick. That was on March 22nd. So These telluric currents are one of the big, you can say, problems for modern technological systems as a result of geomagnetic storms, because the magnetic fields that are fluctuating induce these electric currents in anything that's conductive, in like high power transmission lines, which are super long. They can host these really big currents. They're super conductive because of their aluminum cores, or just any part of the power system in general. Now you get these voltage differences to build up across distance, and that can cause things to break. That can cause things to break, and once you get things to shut down, then you have problems. So thankfully, right now, we are basically fine with just a G2 storm. Very rarely will you have any effects from a G2 storm. But in general, with geomagnetic storming versus non-storming conditions, anyone that's operating these systems, working with satellites, whatever, they're a little on edge. And it's good to be aware of this stuff. It's good to make sure you have just some basic survival stuff. You have some water on hand, you have some food on hand, not only for, like, you know, a potential really big solar storm. You know, in Quebec in 1989, their power went out for like 12 plus hours. All of Quebec was shut down during, I think that was like either way, in Canada it can get cold, right? I don't remember exactly when it was. I think it was like February, but I could be wrong with that. So it's important to be prepared. But also, I just had an earthquake hit me in San Diego, only 5.2, but big ones possible at any time. So just in general, a friendly reminder from me to everyone watching to have some basic preparedness and survival stuff on hand. We can look at our geomagnetic indices, which are similar to the telluric current indices, but they're measuring the geomagnetic field to get a better sense of this storm. We saw the fluctuations on that model, but here we're actually just looking at an index. And so let us zoom into this one here. We'll check out just for today so far, and we'll go like this. And we'll go up to our HB30 index, which is our highest resolution measure of geomagnetic volatility. And if I step over here, we see it's actually low, quiet conditions beforehand. Just a little bit of volatility there at the beginning of the day, but in general, things were below 2. So it's very quiet conditions. You're not going to feel that. Look how quickly this raised up. These are only 30-minute measures. So within just an hour, all of a sudden, we were at a value of 6.33, and then we've even gone above 7 on the HB30 index. So this overall has kind of come down to a value of 6.33 over 3 hours, but we did have 7.33 right there, and then with our HB60 index, we did have 1 hour of 7.33 as well. So quite significant so far, and this is likely to continue. Let's look quickly at our latest sunspot intensitygram to see if we have anything potentially coming up. We really don't have too many sunspots on the Earth-facing side. We had a bunch rotate out. So we have been fairly good recently, but we have this guy right there, Earth-centered direct. If this pops off, we could get something headed our way. Not the biggest probability, I'd say, because it hasn't really done much, but it's there. We have this new one rotating in. I don't know the numbers. I didn't look at the latest synoptic map, so I don't know the numbers, but this should be like 406 something, like 4065 maybe. But that one's actually looking pretty big. Let's punch in on it. And I will have to adjust my display capture here. There we go. So that's looking pretty big. It's not one just big core. It's like a fractured core, which makes that a little bit more unstable magnetically, which is making that, you know, potentially more likely to flare. We've had some big flares from the eastern limb. We'll see if that continues in any way, but that's pretty significant. So we'll have to watch that one closely. And I want to go back actually to our graphic here. And know what? Let's actually load this one up. This one shows it even better. We have our coronal hole on the Earth-facing side of the sun right now. So that is right here. Oh, let's do this. I can move this guy over again. There we go. So this is our past 3 days looking at our 211 angstrom view of the sun, which shows these coronal holes very nicely. These are areas on the sun where the magnetic field is open, the plasma temperature is lower. We also see these eruptions that gave us this solar storm that we're in right now. But this has rotated around now 8 times. The last rotation, number 7, gave us a G2 storm, and then there was a global seismic burst that followed immediately afterwards, lasting for about a week or so. So this is starting to rotate in, and it looks pretty similar to what it did last time. So I don't think it's diminished that much. We'll get a better sense of what this looks like in about 2 days when it's more Earth center direct. We see that it still has this coronal hole feature up here as well. It looks like there may be a bit of connection to them as well. So we're going to get a better sense of what it looks like when it goes more Earth center and direct. But still, let me actually go to the end and pause it for you all. That is a pretty big coronal hole right there. So it's looking like this will be geoeffective on April 23rd, approximately. And we may have a pretty big geomagnetic shakeup then as well. So that is possible. That very well could give us another geomagnetic storm in just about a week or so. So Yowza is right. Yowza. And beyond that, let's talk about Earth's magnetic field a little bit. We have, oh yeah, so we can load that one up. But then let's also load this one up. Let's check out the movement of Earth's magnetic field, specifically the North Pole, over the past 125 years. Here we're looking at the movement of the magnetic pole in the northern hemisphere, a negative magnetic pole, so technically what they call a south magnetic pole, but we call it the north magnetic pole because it's in the northern hemisphere. That's why I call it the magnetic pole in the northern hemisphere. Negative pole. We see that it was here in Canada in the early 1900s. There we see the historic trace going back to 1540, or maybe that's like, yeah, that should be 1540. And look at that rapid acceleration that started basically in the 90s. Had a lot of people very worried. And Earth's magnetic field has weakened from its most recent maximum value, which was about 1,000 years ago. It could be a little bit more than that. It's a little ambiguous, but in general, we do know that Earth's magnetic field strength has decreased about 15%. More like 10 to 12% since 1850s when we started to record this, and then based on archaeointensity data, it's decreased a bit more than that. But it was also back at its maximum high not that long ago. It was anomalously strong. It was very, very strong. So Earth's magnetic field right now is actually quite strong in the historic geologic context. It's not abnormally weak, which a lot of people are saying. It's not. It's actually quite strong, again, in that complete geologic context. But it is slowly weakening, and we are seeing the magnetic fields move. But a lot of people look at this and they get very, very worried because of that rapid movement. Now, one thing I want you to know is that this is actually closer to the true North Pole than it has been in a long time, because it's offset when it's over here in Canada. It's actually quite close to the North Magnetic Pole, like the real, not the magnetic pole, the real North Pole, right, for the axis of rotation, which is right about there or so. That actually might be it right there. So we see it's actually really close to the magnetic pole, and it's not straying considerably from that. It was more off before. But should we be concerned? Let us look at this graphic I have here. This is from a research paper that came out, I believe, in 2011 or 2014. So it's actually been out for a while. Really good research. I'll explain it a little bit. I don't know why people don't present this. I haven't seen anyone else present this for some reason. So what are we looking at? Well, we are looking at the position of Earth's magnetic pole based on different ways of measuring it historically. I'll explain that. Going back to 200 AD. So we have data going back to about 1540 based on a variety of models. And that's all kind of like hidden in there. We see the most recent movement going to 1800 AD like this. And then we see our most recent value there, 2025. I put that in. I updated this graphic myself. So I made sure that was accurate. I put in 2025. They had their last measurement of 2007, an actual observation measurement that was done right there. But this movement from basically 1990 to now is not outside the norm historically, even just for the past 2,000 years. They did a whole bunch of measurements using these different sediments and lakes, and they record the remnant magnetization and the inclination, the declination, the intensity of the sediments because they're slowly filtering down. And so you get this record of the magnetic field. They did that across a lot of Canada. And also other people have done it all around the world. But there are differences depending on where you measure it. So they have a location right there, Lake Murray, which is right basically as far north as you can go in Canada in the Arctic Circle. And they recorded the virtual magnetic pole position based off of those sediments and plotted it. And look at how it's moved. So here's 200 AD, and we see the arrows here going like this. And we see that it did this big loop here around, down through Canada, then did the very similar journey that we're in right now. Look at how close this is. Very similar journey right there, going from 750 AD, and then it moved up, and that takes it to 850 AD. These are 500-year or 50-year jumps. So that's 100 years, very similar movement. Then it did this little circle like this according to these records that they developed. Again, there's going to be a little bit of error here just because it's not an actual absolute recording with a magnetometer for 2,000 years, but they're probably fairly accurate. The research paper is really good. I'll link in the video description once this is over. We see this go like this, and then we see it go down here and start to move down there. Some really rapid acceleration that took place there. Look at this 50 years right there. Really incredible rapid acceleration, 50 years right there. And then we reach this historic position and boom, that's what we show going up. So what we are seeing with the movement of the magnetic pole in the northern hemisphere is not at all abnormal, even just for the past 2,000 years. That's the point that I want to show you. And so you shouldn't be worried about Earth's magnetic field. Has it weakened? Yes. Is it still strong? Based on the historic geologic record, it's still very strong, yes. And the movement of the poles isn't anything that's outside of normal secular variations. I'll be the first one to tell you, if we start to go into an excursion and this magnetic pole really starts to shift down here or way down into lower latitudes, or like the magnetic pole in the southern hemisphere also starts to go way up into the mid latitudes and it's clear that we're in excursion, I will let you know. But we're looking at what is actually happening to the best of our ability and understanding truthfully, and this is it. Now, some of the confusion, just to fill you in, is that this rapid acceleration occurred from 1990 up to basically now. It's starting to decelerate. It's only going about 40 kilometers per year, whereas it was going up to 60 at one point in the early 2000s and mid 2000s. Well, they launched the swarm satellites in, I think it was like 2014 or 2015, and they did some initial data crunching from the swarm satellites, and that confused and worried a lot of people. Let me just pull up this graphic on satellites here, because this is also relevant to our conversation on power grid failures and such. But they launched these magnetometers up into space, which cover the globe with their orbit basically at a very high frequency. But it's measuring the magnetic field strength at a much lower level because it's, again, out in space and the magnetic field decays via the inverse square law. So they published some initial results in that first 6 months. And those initial results were that Earth's magnetic field was decaying 10 times faster than normal. And people have been running with that headline since 2015. For 10 years now, people have been running with that headline. But what they all failed to do is double check, because after a bit more time elapsed, the people running the swarm mission realized that their data was incomplete and that it wasn't decaying 10 times faster than normal, and that they had actually just had a limited data set and they made arbitrary conclusions based off of it. They just got a little ahead of themselves, basically. And that Earth's magnetic field has variations in different places. And we know it's not decaying 10 times faster than they thought it was, or that it actually is at this moment in time, because we have magnetometers all across Earth's surface. This is like the intermagnet network. And they would also record that rapid rate of decrease, and they're not. So that story from 2015, that Earth's magnetic field is decaying 10 times faster than normal, is actually just, it was a press release that was pushed out too early, effectively. And and people have been running with that story ever since. So that's to give you a little bit more information. I know a lot of you watch this channel are interested in Earth's magnetic field. I do have a video playlist that's like 5 hours long on it. I'll link that in the video description also after this video is done. But you don't have anything to worry about. The biggest changes that Earth's magnetic field experiences are basically from geomagnetic storms like right now. This geomagnetic storm that we're having right now is quite significant, and that causes perturbations to Earth's magnetic field that we feel in the human time scale. So that's occurring at this moment in time. We see our most recent model here. It has cooled off a little bit, but we'll see if we go back to G2, G3 levels continuing forward. So these are the magnetic perturbations that are happening at this moment in time. And we don't have anything really headed our way after this other than that big coronal hole that's on the sun, which is not yet geoeffective, but it will be in about 8 days or so. So this geomagnetic storm that we're going through right now is the biggest energetic factor at play at this moment in time, though I do think we have a higher likelihood of increased earthquake activity for the next few days as a result of this, as a result of the ionosphere being a higher level of charge, for a variety of reasons I've explained in my videos over the past week or so. And that could also then continue after that high-speed stream from that coronal hole impact, which will be again April 23rd. So I would say from now all the way to the end of April, there's a heightened chance of there being more magnitude 6+ earthquakes. We're well overdue for a megaquake, magnitude 8+. Talked about that. That could pop off at any moment. We hope it doesn't, but it's been like 3.5 years, and normally they occur once per year, even twice per year, magnitude 8+. So we're overdue on that as well. So I've been your host, Stefan Burns. Thank you all so much for watching. We are going to get into our cosmic connection meditation now, and so we are going to just play some of these instruments that I have, and I recommend that you get comfortable and put on some headphones so you can hear this better. And this is just to help balance and equalize the energies that we're experiencing right now, because we're experiencing these fluctuations all across the world together simultaneously, and that's just a good thing to do. A lot of people love these cosmic connection meditations, and yeah, I recommend you just find a comfortable position. And a quick note before that, if you like what I do, you can support me, and I can support you. This can be mutual support by going to my website, wildfreeorganic.com. I have a bunch of holistic wellness products there. For example, all organic herbal tea blends. These are available to everyone in the United States. Spirituality, tranquility. There's also vitality, electricity, herb coffee, fruit tea. All these are amazing for your health and your wellness. Herbs are nature's original medicine. If you didn't know, 90% of pharmaceuticals are derived from herbs. Hint, hint, wink, wink. So why not just actually get the good stuff yourself and not pay an arm and a fortune for some pharmaceutical derived product that loses out on the synergistic effects of herbs. And if you're a smart herbalist, you can actually start to combine herbs together to increase the synergistic effect, right? The entourage effect. You know, hundreds of phytochemicals and polyphenols, all these things working together to improve your health and wellness, just help you feel good. Spirituality just makes you feel good, rested, relaxed, calm, centered, grounded, enhances your dreams. Excellent to work with during these sort of geomagnetic storms when you already have increased potentiation of dreams. And so you can go to sleep and have some incredible lucid dreams and even precognition dreams if you start working with these energies a bit more consciously. A lot of people are doing that. Go read the reviews, wildfreeorganic.com/store. Also, the earthing shoes are available there. I discussed those at the beginning because of our friend, I believe, James, and his super thanks discussing the Tartarian boots. And the other thing that we'll play with this cosmic connection meditation is this singing bowl here, which I've been wanting to play since this storm started. So, dziękuję. The Furies, thank you for calming us and reassuring us. Yes, everything is fine. Though I do have a crazy thumbnail for this video. But I will tell you as it is. Focus on your breathing. Just pay attention to it. How are you breathing? Breath is life. So you can start to lengthen and deepen your breath. Calm your system. Can you feel the ambrosia, the sacred secretion dripping from the pineal gland? Feel the resonance. We have fun here. This is the sonic slider. The earth is vibing and we are vibing. It's a vibration party. This is for the crown chakra. If you feel it tingling, open up to it. Let the energy flow in. Let it heal you, vitalize you. Welcome back. Hello. Thank you all for joining today, for being part of the live stream, the sound healing resonance healing experience. I've been your host, Stefan Burns. Thank you all again. If you'd like to work with me a little bit more personally, mutual support, again, the website, wildfreeorganic.com. And just in general, your support with the videos means the world. We are closing in on 222,000 subscribers, and so I'm going to do my best to get a screenshot at 222,222, which is an amazing, amazing number. So we hope that that works out. We'll get there soon. Should happen any moment. And yeah. Wishing all of you well. Have a great rest of your Tuesday or Wednesday, wherever you are, and make sure you, stay praised with the energies because they can really affect us. So, recommend you take it easy as best you can, and that will help a lot. I'll be back with more very, very soon, and wishing all of you well. Love and light. Take care.